In this video, I'm going to show a synthesis reaction map for this compound, which is a 1-chloro-1-methyl cyclopentane, changing to a cyclopentanone. So when naming these, this compound has the longest parent chain of a 5-carbon ring, so it is a cyclopentane with 2 substituents, and the substituents are on carbon number 1, and it's just decided that that is the first carbon because it has substituents. So we have a chlorine and a methyl, and when naming those, they are in alphabetical order. So it is a 1-chloro-1-methyl cyclopentane. And this compound has the same long parent chain, 5-carbon ring. It is a cyclopentane, but the carbon-oxygen double bond changes the ending of the name to pentanone. All right. Next, the first step in the reaction is reacting with the leaving group. The chlorine is in a very reactable spot, and chlorine is very reactable itself. It can react with many things, but for now we'll react with hydrochloric acid. And this bond here, the electrons will break and flow to there. Some will flow to that chlorine, some will flow to this hydrogen. And the chlorine will have all these electrons floating off to the side. And same with the hydrogen. And the hydrogen will grab onto this chlorine. This chlorine, the bond between this carbon and the chlorine will break. The leaving group leaves, taking some electrons here. These electrons flow back to this carbon, which will now form the carbocation intermediate. And there is no rearrangement on this carbocation intermediate because it is already on a tertiary carbon, so it's already in a very stable place versus a secondary or a primary. So the next step would be an E2 with a strong base like sodium hydroxide. We may need excess for this one. And there will also be water. And in this reaction, the sodium does not do much, it's just really there. So it'll be the oxygen with an H bonded to it, going after the hydrogen that is away from the carbocation. So it will grab one of these hydrogens to form water, and the electrons here will flow to this carbon, or since they're already on this carbon, they will flow to this double bond and fill a space here with the carbocation. So there's a space to fill. Those electrons from this bond will fill that space and will create a double bond. And there's a carbon here and a carbon here, so it is a methane. And the byproduct, or another product made, is water. The next step would be the water reacting with the 2 free floating pairs of electrons on this carbon. So there's the water. And these electrons here grab onto one of these here. And the water bonds to the double bond. And oxygen is supposed to only have 2 bonds. It's where it's at its happiest. It's where it's at its good, neutral standpoint. So these H's will disperse or distribute out and leave with the oxygen happy and stable with two floating pairs of electrons, like a cyclopentanone.